Myself, Dr. M. David Raju, Associate Professor. Today I am going to discuss about theory of potentiometry. Theory of potentiometry. So let us see what is potentiometry, purpose of potentiometry, and the basic principle involved in this particular potentiometry. It is a technique in electrochemistry. This technique is used in electrochemistry to measure the potential of a titration involving oxidation and reduction simultaneously takes place, that is redox titrations. So in this technique we measure the potential of an electrochemical cell without drawing current. The potential is proportional to the concentration of ions in the solution. More the concentration, more is the potential. Less the concentration, less is the potential of a uh, particular reaction. So the purpose of this one is mainly to determine the concentration of analytes in a solution by monitoring changes in cell potentials. We measure the potential of this. So the potentiometry is widely used in various industries and laboratories. The basic principle in the potentiometry is nothing but it is based on the Nernst equation. Almost all the 80% of the electrochemistry is based on the Nernst equation. This particular reaction tells us uh, the relationship between the amount of the substance that we are taking and the amount of the electricity that can be drawn, that can be generated from that substance. So where here the equation is, that's why this equation is very popular and very important one. E is equal to the first equation, the first scientist who gave a relationship between the quantity of the substance used and uh, the quantity of the electricity generated. The relationship between these two. The scientist name is Nernst, and for that he awarded a Nobel Prize. E is equal to E naught plus RT by NF log A. This is the relation. E is equal to E means electrode potential. The potential that an electrode is bearing, that's called E. E means EMF, electromotive force. The force which motivates the electrons to move is called electromotive force. And E naught is standard electrode potential. And R is a gas constant. T is a temperature in Kelvin. N is number of electrons. And F is Faraday's constant. And A is activity of ions. Now, the working principle here is the potential difference between two electrodes is measured. There are two indicators. One is reference electrode. There are two electrodes. One is reference electrode and another one is indicator electrode. So one reference electrode and indicator electrode. So between these two, we measure the potential difference between these two electrodes. The potential is related to the ion concentration, and more is the ion concentration and more is the potential. More is the ion concentration, more is the potential. Now, components of potentiometric cells. Let us see what are the various components in a potentiometric cells. The first one is reference electrode. It provides a constant potential. it provides a constant with respect to, without depending upon the concentration of the solution, it gives a constant potential throughout the titration, potentiometric titration. The various reference electrodes are standard hydrogen electrode and silver chloride electrode and platinum electrode. So indicator electrodes. So first one is reference electrode and second one is an indicator electrode. So response to changes in the activity of ions in the solution. Indicator electrode indicates the potential of the solution throughout the titration. When the concentration of the solution changes, the potential changes. That potential is detected by indicator electrode, not by reference electrode. Only indicator electrode. We have to remember that the reference electrode potential is constant throughout the titration, but whereas indicator electrode changes, varies according to the titration. So let us see some examples. Glass electrode for pH measurements and electrolyte solution contains the enolite whose concentration is being measured. So potentiometer, or we can call it as a voltmeter, measures the potential difference between the electrodes. See, we find out the potential difference between the two electrodes, and the two electrodes are, one is reference electrode, another one is indicator electrode. In reference electrode, potential is constant throughout the titration. That means whatever may be the concentration of the reactants inside the container, it is not affected by those concentrations. But whereas indicator electrode, it is affected by the concentration of the reactants. So that's a main thing involved in potentiometric titrations. So Nernst equation for a pH electrode is E is equal to E naught minus 0.0591 by N log of H plus ion concentration. E is equal to E naught minus. See, we have seen the Nernst equation previously, where we have seen the Nernst equation previously, where we find E is equal to E naught RT by NF RT by NF. Uh, those values are substituted. Rydberg constant, temperature, and Faraday's constant. Those values are substituted, and finally we got a form E is equal to E naught minus 0.0591 by N log of H plus ion concentration. At 25 degrees centigrade, the equation simplifies to the slope value of 59.1 millivolt per pH unit. Now, types of potentiometry. Direct potentiometry. Types of potentiometry. Direct potentiometry measures the potential directly to determine the ion concentration. Direct potentiometry, it measures the potential directly to determine the ion concentration. So example, pH measurement using a glass electrode. That's a direct potentiometry. Titrometric potentiometry. In this titrometric potentiometry measures the potential changes during a titration process to determine the equivalence point. It measures the potential changes during a titration processes to determine the equivalence point. So example, redox titrations. Redox titrations. So these are the two types of potentiometry. So types of electrodes in potentiometry. Reference electrode, that is standard hydrogen electrode. Reference electrode is standard hydrogen electrode. That is silver chloride, and electrode calomel electrode. Indicator electrodes are glass electrodes. pH measurements for pH measurements. So fluoride, calcium, metal so they are called a selective electrode for specific ions, and metal electrodes for redox reactions. It's a platinum electrode. It's a platinum. So applications of potentiometry in various fields: chemical analysis, environmental monitoring, pharmaceutical industry, food and beverage industry, and clinical and biomedical applications. So thank you very much.